Hello everyone, I am Keerthikumar. So today I am going to do an analysis on effectiveness of the FinFin. So by considering the different parameters which are more significant on the effectiveness of the FinFin. So by using the Minitav software, by considering the different parameters which are affecting the effectiveness of the FinFin. So let's begin. These are the contents which are there in this presentation. Pin fins are the extended surfaces which are used in heat exchangers and the cooling systems in order to enhance the heat dissipation. So by increasing the surface area, and it will increase the overall heat transfer rate. So these are mainly made up of high thermal conductivity materials like aluminum or copper, so that will maximize the heat transfer efficiency. So these types of pin fins are used in wide varieties of applications, majorly in electronic cooling systems, aerospace industries, and automotive radiators in order to cool the coolant oil, and used in some industrial heat exchangers as well. So it works on the principle of both conduction and with the convection. The overall objective of this analysis is to evaluate the impact of the key parameters on the effectiveness of a pin and by using factorial design methodology. And the study aims to identify the significant factors that are influencing the heat transfer performance, so and ensure the robustness against the variations in the operation conditions. These are the key factors I have considered. I have considered the three major factors that are more significant in the effectiveness. First one is the voltage, second one is the current, and third one is the temperature. I have taken voltage in 3 levels, current also in 3 levels, and temperature in 2 levels. The temperatures, I have conducted the experiments in the morning and the afternoon. So in the morning, the temperature is around 25 degrees centigrade, and the temperature is nothing but the atmospheric air temperature. So the air will flow on the pin fin in order to enhance the heat transfer rate. So in the morning the temperature is around 25 degrees centigrade, and in the afternoon the temperature is around 32 degrees centigrade. So I have conducted the experiment in the morning and in the afternoon as well, in order to get the different combinations of these parameters. So the total 18 experiments were conducted, and all the data of these 18 experiments are collected, and analysis is done in the Minisoft software. So initially we have to take the 18 different combinations of these three factors in order to do the analysis. So initially, so we'll take the 18 combinations of the factors, and I will conduct the experiment and get the data and calculate the effectiveness and efficiency for the of these 18 experiments. Then I will go forward with the analysis in the Minisoft software. So let's see how to take the combinations of these three key factors in the Minitab. Let's do the analysis in the Minitab software. Just go to start, and then DOE, then factorial, and then create factorial design. So here number of factors I have to select, so I am selecting the factors 3. So 3 factors I have selected. So the design, so here I have to give the names for the each and every factors. So I'm name it as voltage, and then current, and then the temperature. So these are the 3 factors I have selected for the analysis of the effectiveness of the fin. So the number of levels also I have to give here. So the number of levels for the voltage I am giving 3, and for the current also I am giving 3, and for the temperature I am giving 2. So here in the previous slide also I have explained the 3 values of the these 3 factors. So then click OK. Then in factors here, in the level values, I have to give the values of the level like 65, 70, 75 voltage, and current 0.4, 0.5, 0.6, and for the temperature 25 degree and 32 degree. So that way also I can do. Otherwise I can just keep it as same only. Afterwards I can just replace with the number 1 with the first value, 2 with the second value, and 3 with the third value. So both ways I can do. So I'm simply keep as it is. Afterwards I will change. So just keep it the same only. So click OK. So here the design summaries get generated, the factors 3 based on 18. So here we can clearly see the 18 different combination of values is get generated. So the column C5, C6 and C7 representing the voltage, current and temperature values. So the 18 rows will get generated for 18 combinations, the total 18 runs. So here I can just replace the number 1 with the first value, and number 3 with third value, and 2 with the second value of the level. So I've just created on separate Excel sheet, and there I have just enter the data accordingly. So I'm just here copying, and I will just paste it over here. Otherwise if I directly enter the different 3 values in the minute of software itself, then it will automatically generate the 18 different combinations. So here I will simply replacing the values with this first for 1, 2 and 3. So both the ways I can do. The first one is the simplest one. So I'm just paste it over here. So here the 18 different combination is get generated. So by using these 3 inputs, I have to conduct the experiment and get some data. So based on that data I have to do the analysis part. So I have to do the analysis. So first just conduct the experiment. So afterwards we can move forward with the this analysis part. We have seen how to take the different combinations of the factors. So let's conduct the experiment. So this is the operators I have taken in order to do the analysis, in order to conduct the experiment. So this operator is consist of an air duct with pin and then a blower with a motor, and then a U2 manometer, and a speed regulator, and temperature set switch, and the voltmeter, ammeter, and the temperature indicator. So this is the experimental setup. This is the procedure to conduct the experiment. Initially the heater switch is on, heater will be switched on, and the voltage and ammeter readings are set to the required value, and after the blower is switched on. So in order to force the air over the pin fin, and the difference in the head across is noted, and after steady state is reached, then various temperature are noted under the forced convection condition. So after that, by using some formulas, the calculation will be done, and by that we will get the effectiveness and efficiency of the pin fin. This is the tabular column of the experiments. The totally 18 experiments are conducted, and the data of the 18 experiments is taken, and by using the mathematical calculations, by using some formulas, we have found out effectiveness and efficiency of the fin for different combinations of the 3 key parameters which I have selected. So by using these data, let's see how to do analysis in the Minitab software. After conducting the experiments, so I have calculated the effectiveness value for each and every run, so each and every combination of values. So let's so I have just stored the effectiveness values in the Excel. So I will just now move forward with the analysis part. So let's continue with the analysis part. So I will just copy the effectiveness value, and I will just paste it in the Minitab software. So give me a second. So I'll just paste it over here. So some small mistake has happened, so let me correct. So I'll just delete and I will just copy again. So these values I have to copy and I have to paste it in the Minitab software. So I'll just paste it over here. Yeah, that's it. So this is the effectiveness value. So to do the analysis, go to start DOE and then factors and the analyze factor design. So that I have to select effectiveness as my response. So select in the terms voltage, current, temperature only I need. So I will just remove all other things, AC, BC and ABC combinations. So I don't want those things, so I'll just removing those things. So then click OK. Then keep it all the remaining things as it is. In here also keep the things as it is. Go to graphs, here also here select the 4-in-1 graph. So we'll get all the graphs. So in the results keep it as it is, and in the storage we have to select fits and residuals. So these are the things required in order to conclude the analysis. So other is also required depending upon the different applications. So the analysis is over. So this is the output value. So 1 second. So this is the output. So the factor information and ANOVA table, here also we can come to a conclusion. So it is the model summary, this is the coefficient table and the regression equation and fit and diagnostic for usual observations, and this is the Pareto chart I have got here. This is also required, and residual plots also I have got. So the plot is required. In order to get the plot, go to start, then select DOE and then factorial, and then here select factorial plots. So I'm selecting factorial plots. So here I have to select the all terms. So all the terms are required. So the options keep it as it is. So the graphs, it has a main effects plots and interaction plots I have need. So view model, in it is also same. So click OK. So then plots will get generated. So this is the plots, different plots. So here we can get an idea about how the parameters are affecting the effectiveness, and in which combination we will get more effectiveness. Those things we can easily get to know. So that's all about the analysis. Let's discuss the each and every graphs and plots in detail, and let's come to a conclusion. Since the full factorial design is selected, the voltage is taken in 3 levels, and current is taken in 3 levels, and the temperature is taken in 2 levels. So totally 18 experiments will be conducted, and this analysis involves the factor interaction study and the data driven insights and optimization and the robustness and the result interpretation. So we can see clearly know. So we have seen how to do the analysis in the Minitab software. So these are the results I got from the analysis. So this is the table of analysis of variance. So here we can see the p values and f values for the all the key parameters. So for the voltage, the p value is almost 0. So I have considered 5% significance level. So the voltage is having the lesser p value and the greater f value. So we can say the voltage is the more significant factor. So current is also significant, but in comparison with the voltage, the current is causing less difference. So this we can observe in this ANOVA table. I have got the different plots of this analysis. So this is the normal probability plot. So this is the residual plot. So in order to make sure that the experiment is normally distributed, the point should be scattered near the this red line. This is a significant line. So we can see all the points uh, are very near to this line. So only few of are so far away from this line. So we can say the experiment is normally distributed. And here also we can say in the histogram versus residual versus frequency graph also we can easily say uh, the experiment is normally distributed. So this is the residual versus fits. So here the points are scattered randomly, so it is not following any pattern over pattern over here. So here so there is no error which are there during the analysis. If we see any pattern in this fitted versus residual, so there are some error will be there. So we have to make sure that all the points are scattered randomly. So here there is no error during this experimentation. Here also we can clearly see there is no pattern it is following. All the points should be continuously varying, so one should not should not follow any pattern in order to say it doesn't have any errors. So here also we can ensure there is no errors during this experimentation. This is the Pareto chart of standardized effect. So as I said, I have taken 5% significance level. So this is the threshold point, that is 2.179. Any key factor that exceeds the threshold point is more significant. So here we can clearly see the A is nothing but voltage is crossing and it is reached beyond the 2.179, that is the threshold point. So the current is also crossing this threshold point, but the voltage is more significant here. Here also we can confirm the voltage is more significant. We saw that the current and voltage are more significant, but here we can confirm at what value we will get the more effectiveness. So in this first plot, that is current versus voltage. So the blue line indicates 0.44 amps, the red line indicates 0.5 amps, and the green line indicates 0.6 amps. So here we can see at 0.4 amps with 65 voltage we are getting more effectiveness. So and here also it is temperature versus voltage. Here at 25 degrees centigrade with 65 voltage, 65 volts we are getting more effectiveness. And in current also we are current versus temperature graph also we can see at 0.4 and 0.5 amps we are getting more effectiveness. So here we can confirm with lower value of voltage and lower value of current is giving us the more effectiveness, and temperature is not causing that much difference. Yeah, that point also we can confirm here. In the main effect plots for effectiveness, here also we can see for each level of the voltage, the change in effectiveness is very huge. So in current also for each levels, the effectiveness is changing very much, but not comparative with the voltage, it is less, and temperature is not causing that much change in the effectiveness. So the conclusion from the analysis is the decision is the voltage and current are the key factors that are controlling the effectiveness. For higher effectiveness, the lower voltage and the lower current are recommended. The temperature variation does not impact effectiveness significantly, and model validation is satisfactory, so the conclusion can be relied upon. So from the ANOVA table, we can say the voltage is the highest adjusted square sum of square, that is 8.2866. So it contributes the most effectiveness. The current also has a significant with adjusted sum of square of 2.0752. The temperature is very low adjusted sum of squares, that is 0.0207, meaning it does not significantly impact the effectiveness. So in the residual plots also, There are no strong patterns or observed, so that the model is valid. So the residuals are mostly normal. So assumption of ANOVA hold. The model's conclusions are reliable. So that is the final conclusion of this analysis. That's all about analysis of effectiveness of the FinFin over the key parameters like voltage, current, and temperature. Thank you so much.